shut down release today. Okay. You'll have to shut down, clean up some of these methods. Okay, here what I would suggest is oven, we would set this to 60. And let, keep all the flows the same.
Mm-hmm.
We could set these to 0. Whoops. And then yeah.
Also there's what 1 minute.
Oh, 1 minute. I set it to 60. It's what it's going to do is if you try to run this method, it's going to take a really long time for everything to cool down, so the oven's not going to ready up. It's good. Like,
Fine. This is ready, and then we can shut down, right?
well, once it says you don't have to start the run, it's going to load these parameters on the GC, and then it's going to just cool everything down until you get to the set point, and then it's just going to sit in the ready state. So it'll reach those set points, and then it's just going to sit there until you do something. You don't have any reason to inject the sample, so you can just clear the setup at that point.
You said it takes about, if we're starting from things shut down, it will take about 8 hours.
Start up? Probably closer to 3 or 4.
But then if we're from standby, that will be ready from standby.
So I would from standby, I would say you're going to need the FID to come up to temp. So from 125 to 250, let the gas flows settle. I would say probably 30 minutes.
So it depends on how long we want to wait before we can actually experiment.
Yeah. If we want to do any manual changes on the touchscreen, right now we're in control. We would click this button and release control.
Okay.
So do we want to try to load up that standby method then?
Now you.
Or are you going to do injections tomorrow?
So what's currently you want? You shut it down or you stand by?
Shut down.
Shut down.
You're gonna turn it off tomorrow? So
Tomorrow we're not using it, so it's fine.
okay. So what we can do is load a method. We'll load the shutdown method we just made. Okay. It loads it like it's loading a run, right? So if I'm gonna hit OK, base file name is blank. Just this doesn't have to be anything.
So will it be any issue? So we use the software there and then turn it up from here. Directly switched off.
When it's ready, when it's shut down, method is ready. That means you can shut down.
Yeah, you're gonna. It's a bit of a kludgy way to do it. This is a way to do it in like an automated fashion, as opposed to somebody. What was that beep? Yeah, because the gas was off. Okay.
Okay, it works. That means it works, right?
It means the method was sent over here. Yeah, if we look at the parameters now,
Yeah,
you'll see the oven. You'll see the pack columns coming down, and you'll see the FID is off because the air is off.
So give the result into the result.
And so what is going to happen though? Once everything is cooled down, it will say ready, and then I would go to run, and then just hit clear setup, and then that's going to just, instead of actually running anything, because what we're doing is essentially loading one method that's going to run a sample actually. And so it's set up like it's going to run a sample. If you clear that setup whenever it's ready, then you can shut the GC off, and you'll be happy when you notice that you won't get errors. If you just shut it off with the setup loaded over there, things are going to lock up. And it's going to clear setup and then shut down. And just flip the switch, close your gases.
So when you want to run the experiment and turn on the instrument, we just turn on the machine and then we don't do we need to do any command from there before using control, release control from here, taking control from to the software.
I missed your question.
So if you want to run an experiment, like a fresh experiment, instrument was turned off, we turn it on. Do we need to control any parameter from here?
Yes. So when you turn it on, it's going to be in that initial state, and that was left at. So that method with the injector methanizer temperature is going to be.
Well, essentially, we know the clear setup. How do I make the clear setup come out?
Oh. So it's a left click.
Left click on the run.
So I would work from the touch screen.
Okay.
I would increase the hydrogen flow to 45 mils per minute, so off of your FID screen, and then I would let this system sit like that for 2 hours until I start to increase it, because then you're going to need to increase the temperature of the methanizer.
I mean, like to increase the temperature, should we come
I
out
would do it from here.
Oh, I see. That's what I'm asking.
So that means it should be the standby first, and then shut down.
You have to shut down. If you want to continue work, you also want to save gas consumed, so you can standby.
Yeah, so because its startup process is going to take a couple hours because of the methanizer, if you are going to save gas over the course of the night, if we're like your experiments are done for the day, but you're going to pick up tomorrow, you can save gas by using the standby method, which essentially the standby method is just there to keep the methanizer hot and then keep gas flowing.
Yeah. So to increase the temperature, what should I do here?
Well, I'll show you what the GC
Okay.
downstairs
Okay,
says
great.
that. One thing I want to check right now is just curious to know what's coming out of FID. Yep. And we have the flow rate here set to 15. And then this is set to 10, and I'm just measuring 28, so it's what I would expect. Cool.